Hey Pre-Calc, Mr. Rashid here, and today we're going to be calculating the exact value of a trig expression using the sum and difference identities. So essentially, we're going to find the exact value of these trig expressions. We're not going to use the calculator, and we're also going to use the sum and difference identities. And if you're wondering where those come from, then watch my video, Sum and Difference Identities, the origin story for that. Okay, so the sum and difference identities are these identities here, which you've seen already if you watched the other video. Now remember, sine keeps the same sign, so it's plus. Sine A plus B stays a plus. Sine A minus B stays a minus. And then sine likes to mingle, so it mingles with cosine. So that's one way to remember that one. Then cosine changes sign, so plus goes to minus, minus goes to plus, and then cosine does not like to mingle. It likes to stay with cosine. That leaves sine by itself as well, sine and sine together. Then with tangent, we have the same sign in the numerator, so minus, minus, and then the opposite sign in the denominator. So if the numerator is negative, then the denominator is positive. If the numerator is positive, it's negative. Okay, so have those written down or printed out somewhere so you can have those accessible when you're doing these problems. Okay, so the first one we're going to do is cosine of 75, and we're going to use the sum and difference identities. And finding the exact values again means we're not using a calculator. We want to get the exact values in terms of square roots and things. So the first thing that we do is we write down 30, 45, 60, and 90. Okay, and then if they're over 90, you may need to bring 180 into the mix, and then if they're in like a third quadrant, you may need to bring 270 in the mix. If it's a very large angle, then just keep subtracting 360 until you get something between 0 and 360. If it's a very small negative angle, keep adding 360 until you get, once again, something that's between 0 and 360, and then you should be able to use this method. So we know, why did I write these values? We know the sine and cosine of those, and we can always get the sine and cosine of these using by drawing triangles, or the 90 is right on the unit circle. So using the operations plus or minus, how can we get 75 degrees? Which one of these could we use? And one thing I can see right away is if I had 30 and 45 and I added those, then I could get 75. So I rewrite this as cosine of 30 plus 45. Now we use the identity, the sum identity for cosine. And remember, cosine does not like to mingle, so it's cosine of 30 times cosine of 45 minus, remember the sign changes on the cosine one, minus sine of 30 and sine of 45. Now, you can use the unit circle to get these values, or you can draw the triangle. So for 30 degrees here, I have opposite is 1, hypotenuse is 2, and the long side is square root of 3. So the cosine of 30 is square root of 3 over 2, and the sine of 30 is 1/2. Then for the 45, 45, 90, I can draw that one as well. So 45 degrees, I've got 1, 1, square root of 2. So that's going to be cosine of 45 and the sine of 45 are the same. They're 1 over the square root of 2. or I can also write square root of 2 over 2. So that is square root of 2 over 2. And I got a minus. So let's evaluate this. This is square root of 6 divided by 4 minus square root of 2 over 4. And then I can write this as square root of 6 minus square root of 2 over 4. Let's erase and meant to get that in there. Square root of 2, and you can leave your answer like that. So that is the final answer. All right, so let's check out another one. So sine of 7 pi over 12. Now you can work in radians perfectly fine and get the sum and difference. Just work with the appropriate values and you should be able to get it. But let's work in degrees since we're more familiar with degrees. So 7 pi over 12, if I multiply that by 180 over pi, I should be able to change this into degrees. So 7 times 180 is 1260 divided by 12. This is 105. So I'm trying to find the sine of 105 degrees. Now, same thing as we did in the last problem. I've got 30, 60, 45, 90, and I've got the operations plus or minus. So which one of those operations could I use and which numbers could I use? So in this case, I can do 60 plus 45. So this is sine of 60 plus 45. And then use the sum identity again. So sine of 60, cosine of 45. And then that is plus sine of 45 and cosine of 60. Okay. Then draw the triangles. So 45 is 1, 1, and square root of 2. And 60 is the long side. Long side is square root of 3. So the sine of 60 is square root of 3 over 2. Cosine of 45 is 1 over square root of 2, or I can write square root of 2 over 2. Sine of 45 is 1 over square root of 2, or I can write square root of 2 over 2. And cosine of 60 is 1/2. Okay, so multiplying all this out, this is square root of 6 plus square root of 2 all over 4. That's it. That's my answer for that one. Okay, so now I've got tangent of 15 degrees, same thing we did in the previous problem. So I've got 30, 45, 60, 90, and I can only use plus or minus. How am I going to get 15 degrees? So I can use 60 minus 45 is 15, or I can use 45 minus 30. So this is tangent of 45 minus 30. Okay, so let's write this out. So tangent, remember, we're following, if it's a minus, then we follow the minus in the numerator. So it's tangent of 45 minus 30, all divided by, and remember, if it's a minus on the top, it's a plus on the bottom. And then we multiply the two tangents down here. Okay, so let's draw our triangle. So 1, 1, square root of 2, this is the 45. And so the tangent in that case, tangent of 45 is equal to 1. And then the other triangle, I need a 30. So 1, square root of 3, and 2. So the tangent of 30 is 1 over square root of 3, or square root of 3 over 3. Okay, so let's plug some stuff in here. So this is equal to 1 minus square root of 3 over 3, 1 plus, and now this tangent of 45 is 1, tangent of 30 is square root of 3 over 3. Okay, so let's let's multiply this by 3 over 3, just so I can get the same denominator here. So this all ends up being 3 minus square root of 3 over 3 divided by 3 plus square root of 3 over 3. And then this is 3, the 3's cancel, so 3 minus square root of 3 divided by 3 plus square root of 3. And you could take this further, and this is totally optional. You can use the conjugate to simplify this. So 3 minus square root of 3 over 3 plus square root of 3. So I could multiply this by 3 minus the square root of 3 and this by 3 minus the square root of 3. Now let's see where this goes. So this is this is going to be 9 minus 3 in the denominator. And then in the numerator, I have first times first is 9. And negative 2. This is a perfect square trinomial. And then square root of 3 times square root of 3 is just 3. And then that's positive 3. Okay, so I've got 12 minus 2 square root of 3 over 6, and I can simplify that to be 6 minus square root of 3 over 3. So not too much different. Either one of those is fine. It's totally optional, that step, except the first answer is correct also. Okay, last problem. Secant of 75. So we've got 30, 45, and 60 and 90, and we got plus or minus. How are we going to get 75 degrees? I think we had one already. We did 30 and 45 and added them. So this is equal to the secant of 30 plus 45. And so now we secant, we don't have an identity for, but secant is equal to 1 over cosine. So 1 over cosine 30 plus 45 is equal to the secant of 30 plus 45. Now we can use our sum identity for cosine. So this is 1 over cosine of 30 times cosine of 45 minus, remember cosine doesn't like to mingle and it changes sign, so sine of 30 sine of 45. Okay, so some of these values we worked out already in previous slides here already in this presentation, so I'm going to go through this one rather quickly. So this is 1 over cosine of 30 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Sine of 30 is 1/2, and sine of 45 is square root of 2 over 2. All right, so then this becomes here 1 over square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. And then here is square root of 2 over 4. Then combine together 1 over square root of 6 minus square root of 2 over 4. And then I'm going to take just the reciprocal of this. So this is 4 over square root of 6 minus square root of 2. And that's the final answer for that one.